Bismillahirrahmanirrahim. Dear class 9-10 and SSC examination students, especially of English version, a warm welcome to you on behalf of Edulight. You know that for a couple of days, not a couple of days, a couple of weeks, we are trying to reach to you, the English version students, to give you something special that no online coaching centers usually do or perform. So I think that this class will be beneficial to you, especially the English version students, and as well as the O-level or English medium students can also join us. But I don't know exactly that whether you have that topic or not in your O-level syllabus, but I will try my best to continue in English, but during my lecture I will try also for better understanding I will tell some sentences in Bangla, so that the English version students especially can understand, because many of the terms cannot be understood easily through English, because as we are Bangladeshi, we are born Bangladeshi, we need to know some of the Bengali words or sentences as well to have a clear understanding of each of the topics in Bangla alongside with English. Okay. So let me give you the introduction of today's lecture. Today we shall discuss the chapter named Refraction of Light of physics book of especially the science students who are watching here. It is made for especially for you. I have prepared the lecture for the physics subject. The chapter name is Refraction of Light. So without further ado, we let us proceed on to our main lecture. Okay, let me let me share my screen at first, so that okay. I think the screen is visible to all of you. Okay, so welcome all to the lecture series, and at first I want to tell you that I will take this topic of refraction of light into two parts, and I will be discussing on the part 1 only today, as because the topic is very extended and elongated, according to me, so it can't be finished within 1 hour. Within 1.5 hours, I think it will take today. At first, we have to know what is refraction of light, because without knowing the basic or the most fundamental definition of about which we will be going through today, it will have no necessity to you, the science students, to have a knowledge on refraction of light. Okay, so you have to know at first the definition of the refraction of light. What is refraction of light and how does it operates when light incidents on a ray through a surface? It will be discussed further on the when we'll continue the video, continue the lecture. So at first we will be seeing a video demonstration, so that you have a basic idea of the refraction technique or the refraction principle. Okay, pardon, because as the video don't have any sound or audio, you can be hearing any
Have you observed the path of light
type of
when it
sounds
enters from
here.
one medium to another in daily life?
Okay. This is
Does it
the
use a long straight line
refraction.
path?
Okay, let me at first bring the pointer. Okay,
Or changes its direction?
this is the thing that
Let us observe
when
some
the
of our
light
day-to-day
incidents on a
experiences.
from one medium
For
to one
example,
medium,
wet
then it
pencil,
will bend,
partly immersed in
as
water.
you have seen,
It appears to
and
be
this is
broken
the
at the interface
mainly
of
the
air and water. A clear pool of water
Okay.
always appears.
sorry. Okay. Let me at first. Okay.
Life.
You can see that this is the technique from which the refraction of light is immersed as a subject or topic in your physics, that you have obviously seen in your previous chapter of physics about the reflection of light. And reflection, what it does, that during the reflection of light, when light incidents on the same surface, especially mirror, on the same surface, it will reflect back to the original position from where the light is incident. That means it will reflect back to the original position. But in case of refraction of light, you can see that from the video demonstration that after it incidents from one medium, let's say this is air medium. This is usually we give example through air medium. So it incidents from air medium, and when it incidents and falls on the glass slab, this is a glass slab, rectangular glass slab. When it incidents on a glass slab, instead of reflecting back to the original medium, the first medium, that means the air medium, it bends a little. And why this happens? It is because for the refraction of light principle that I have said before from the beginning of my lecture, that is it is the refraction phenomenon of light for which the light bends through another medium when it incident is mainly the refraction of light, which we are calling reflection of. Okay, let's see clearly here. Okay, let us see again. When is a pencil is partly immersed in water, you see that okay, another. Okay,
that is broken at the interface of air.
Okay, you can see that when a pencil is immersed in water, partly, not fully, as because half of the pencil can be seen visible on the air surface and half of the pencil is seen visible on the water surface. You can see that the pencil looks like that it has become larger, and it appears also at the same time to be broken. See, the pencil is immersed at this point, but the visible the image, or the yes, that is it is the image. So the image is seen visible at the water, like a broken part of half a broken part of a pencil, and it looks larger than the original pencil, or that means the original object here is the pencil. So why this happens also? This happens also because due to the principle what we have called before, that is refraction of light. Okay, I think these two phenomenon it will be enough for you to discuss, to have a basic concept of the topic reflection of light, of the definition. Okay, now I have to tell you one thing before that. The thing is that before going in the physics physics new syllabus of your NCTB curriculum, I am saying specially for the English version guys, English version students, you may have observed that on the previous years, I think 2 or 3 years back, the physics book had a syllabus different than that of the present one. That means the present syllabus of the physics is not the same as the before one, and it is seen the mostly things that the most of the important topics of the physics, especially in case of refraction of light. I have observed while making the slides for you that many of the important topics of the previous syllabus physics book have been deducted on the have been deducted, and many new things has been included without explaining the thing, why the new things have been included and why the new topics that has been included, the principle that is happening on the new topics, why this happens. That means the prerequisites were not discussed on the are not discussed on the present physics syllabus book. So what I have done that I have taken the previous syllabus physics book, I have and observed some of the important topics that I should include in order to have a clear idea of the new syllabus books topics that are introduced as a new one, but no background had been introduced there. Okay, so this is the part of the previous syllabus physics books. Okay, I have আমি এটা আসলে বলতে চাচ্ছি কেন, I have I'm mainly telling you this because that's because many things are I think it will not match your current syllabus of the physics or the current book which has been written by Professor Jafar Iqbal of Shahjalan International University. You know him better. So okay, without further ado, let us proceed. Okay, so this is mainly okay. At first, let us go to the let us take my pen. Okay, so here is the principle that is mainly discussed, that was mainly discussed before on the video as well as on the lectures, as well as on the on the video. That is that when light incidents from one medium, that is here the air, to the glass, it will bend instead of reflecting. That means instead of reflecting back to the same medium, what it will do, it will bend on the another medium instead of going on the same path that the incident ray also goes. So you can see that here two things are happening. At first, the light incidents, then it will not reflect. Instead of reflect, it will go to the another medium, it will intersect to another medium, and it will go to the another medium, and without and at the same time, without going straight. That is, this is the mainly the line that the line of the light ray should go, but instead of that, what it does, it will bend angle, and it has gone through this direction. This is the original direction for which this phenomenon is happening, and this phenomenon is mainly called what we have been discussing from the beginning, that is the refraction of light, or the refraction principle of light. Okay, so this has been discussed here. The mainly the things what that it has been discussed is mainly this figure in brief or geometrically, what I have told before just couple of minutes ago. Okay, so on the next case, this may also occur. That means instead of light incidenting from air, what it will do, it is now incidenting on the glass medium. Here you can see incidenting, the light ray is incidenting from the the light ray is coming from the glass medium, and it will incident on the air medium at this point. After incidenting the the light ray on the air medium, what it will do, like the previous thing, that is instead of going straight through this line, it will go through this line, and you can see that there has been created two types of angles. This is one angle that is called I, or in English it is called incident angle. Why? That's because the incident ray has created an angle with the normal. This is the normal, that is an B n prime, and B n prime is the normal here. Why it is normal? Because it is perpendicular to this axis, that is, this is the x-axis. You can think PQ is the x-axis and n prime is the y-axis, and we know that x and y axis in coordinate geometries are are perpendicular to each other, or that means they are normal to each other. So as a result, this is the normal, this can be called as the normal to this line. Okay, so that's why we are calling it as normal. Okay, so at the normal it has created an angle which is called I, and on the refraction part it has created an angle which is called R with the normal. So you can see that here I, that is the incident angle, is greater than R, or the refracted angle. But in this case the opposite phenomenon is seen, that is small I is less than small r. Why it is happening? Why instead of the previous one, that means I is greater than R, I is seeing less than R? Okay, this phenomenon is also important. So this thing is also important. Okay, so I am also discussing it. This happens mainly because of two things. One is that the refractive index, which we will be discussing on the future slides. You will see today, or not after tomorrow, or on another part. It will be discussed in this part. So what is happening here, that light first I have said the reason, মানে আমরা যে প্রথম রিজনটা বললাম সেই রিজনটা কি, সেটা হচ্ছে রিফ্র্যাক্টিভ ইন্ডেক্স. ওকে, আই এম টেলিং ইট বাংলা বিকজ অফ বেটার আন্ডারস্ট্যান্ডিং. ওকে, then on the second part, what we are seeing, what is the reason, the second thing for which this is happening is because light in this case, এই কেসের ক্ষেত্রে, হ্যাঁ, from in this case the light is going from rarer, air is the rarer medium. Okay, why rarer? Because it has density, that means rho v, or you can say rho much less than that of glass, that means this medium. So as it has less density or rho, which you have already been it has already been discussed on the 4th or 5th chapter, I think, of your physics book, in this class of this class. So what is happening, that the density of air is less than the density of glass. Okay, and for that air is called as it is less denser medium, so it is called rarer medium. And as glass is more denser than air, so air glass will be called denser medium. Okay, denser medium. Okay, when now the principle is that when light incidents from rarer medium, which is in this case is air, to the denser medium, which is in this case is glass, what it will do, it will refract at an angle such that I is greater than R. Why? Because as glass is denser medium, glass যেহেতু denser medium এই জায়গায়, for that what is happening here, that here is that instead of the light has bent, at the same time the angle which has been created as the refracted angle is seen less because of being denser. That means there is something more components present than that of air. Okay, that's why the refracted angle is seen smaller than that of incident angle in case of this case, in this first case. But in this case, as we are going from the denser medium to the rarer medium, that is air, and denser medium, that is glass, instead of the angle, the refracted angle here is created, will be automatically, not automatically, will be naturally, according to our concepts, should be higher, because it has lesser components. Air has lesser components or lesser elements than that of glass. So that as a result, here we can see that I is less than R, and in this case we are seeing I is greater than R. Okay, this is the main phenomenon. Okay, now I have said before a couple of minutes ago that what is refractive index in Bangla. If we said that refractive index কি বলছি আমরা, তাই না? What we mean by the refractive index. Okay. This portion of your slide is taken from the present syllabus book. That means the present syllabus that or the present book that is currently available on you among you. Okay. According to this book, this refractive index is being given, the definition of the refractive index here is given a much more better way than that of previous syllabus. So I have included this part. Okay. So what the this portion is saying, or this book is saying, this part of the book is saying about refractive index is that in order to understand the refraction, a quantity named refractive index is used. Okay. We know that the velocity of light and when it passes through medium, it velocity decreases. That means যখন when অথবা যখন তুমি কোনো লাইট অথবা কোনো ভ্যালোসিটি অফ লাইট ভ্যাকুয়ামটা কি বেশি হয়ে যাচ্ছে, কেন বেশি হয়ে যাচ্ছে আসলে, আচ্ছা here we have to see another thing, that this is not 2.99 into 10 to 108. It should be the velocity of light is 2.99 into 10 to the power 8 if we denote in meter per second. This is the scientific notation which you have already studied on the first chapter of this physics book about the scientific notation, how to donate the scientific notation, and as well as on the exponential chapter, which has been, that means in Bangla সূচকীয় এবং logarithmic the function সূচকীয় এবং logarithmic, that means exponential and logarithmic functions, in where you have also been introduced with this scientific notation of words. That means 10 to the power 8, 10 inverse 1, 10 inverse 3. I'll not be going to throw that because as this is not my topic today. Okay. For the clarification or the correct option, or which should be the correct thing or data, I have included here. It shouldn't be this. Okay, this is the wrong information of the velocity of light. Okay, that's okay. And when it passes the medium, this velocity decreases. Okay, it is saying that when it goes through another medium which is obviously denser than vacuum, because vacuum is the most rarer medium of this universe. Yes, this is the correct or fundamental truth, that is vacuum is one of the medium that has vacuum is one of the medium that has a lesser amount of components. That means it is practically no components. This vacuum has no components in it or no mixtures or other things in it. So it is called the purest compound or purest component or medium. Okay. So any medium from which light will incident from vacuum to any other medium should be, so as a result, denser. So as it will be denser, it will be seen that the velocity of that medium will change gradually, and this change will be what? It will decrease gradually. Instead of being increase, it will decrease gradually. And why this happens? Because of the refractive index, by which we can give a clearer idea. You can see from here. And that means not we can in this your present syllabus, it has been denoted as n, but you can denote refractive index as this symbol also. This symbol also. Okay, this is oh sorry, not it will be clear. Okay, this is a symbol which will denote the refractive index of any medium. But if you write n, it will not be wrong. Instead it will be correct, because it has been given on the book, it has been expressed through n. So what is happening here, that in order to find n, the writer of the book, what he has done is that he has divided the velocity of light with the velocity of a particular medium. Say this can be velocity of any I suppose any air medium in any place. Let me give you example as an example that the velocity of air in any area be, let it be this. So when we take the ratio between the velocity of light and the velocity of light in vacuum and velocity of light in any medium that is obviously denser than vacuum, what I have said because before, that is air medium, I will see a multiple or integer multiple. This integer multiple is mainly this refractive index. That means refractive index is mainly denoting how much, what should be the velocity of light in that medium times that refractive we can define refractive index that is by this that velocity of light in any medium will be n times smaller, or velocity of light in vacuum will be eta. This is called eta E T A. If we express through this the refractive index as eta, then it will be called eta. So this is a Greek word. So eta, if we express refractive index as eta, then velocity of it will mean that velocity of light in a vacuum will be eta times greater than the velocity of light in water. In this case, as eta value or n value is 1.33, so we are saying that velocity of light in vacuum is 1.33 times greater than the velocity of light in water. Oh, this is the velocity of light in water. I hope on the before. Oh yeah, there was already specified about that it was the velocity of light in water. Okay, that's not our big deal. Our big deal is that what generally refractive index generally means to all of us. So that means refractive index, what it generally means in case of connection between vacuum and any medium. Of course it will be, and at the same time of course it will be denser than vacuum. মানে যেই মিডিয়ামটাই ধরতেছি না কেন সেই মিডিয়ামটা কি অবশ্যই ভ্যাকুয়াম যদি ভ্যাকুয়ামের বাদে ধরি সেটা কি অবশ্যই ঘনত্ব বেশি হবে, দ্যাট মিন্স ডেনসিটি উইল বি গ্রেটার। সো অ্যাজ আ রেজাল্ট কি হচ্ছে, তোমার কি ভ্যালোসিটিটা যেহেতু তোমার ডেন্সার হচ্ছে, এই জন্য কি ভ্যালোসিটিটা আলটিমেটলি কি কম পাওয়া যাবে ভ্যাকুয়ামের চেয়ে। এই জন্য যেহেতু কম পাওয়া যাবে, এই রিফ্র্যাক্টিভ ইন্ডেক্স সেটাই মিন করবে যে কতটুক টাইমস কম পাওয়া যাবে ওই মিডিয়ামটায়, যে মিডিয়ামটা ডেন্সার মিডিয়ামটা বলতেছি আদার দ্যান ভ্যাকুয়াম, কত টাইমস স্মল পাওয়া যাবে, দ্যাট মিন্স ভ্যালোসিটি অফ ভ্যাকুয়াম কত টাইমস গ্রেটার ওই মিডিয়াম থেকে, দ্যাট মিন্স হেয়ার দ্য ডেন্সার মিডিয়াম। ওকে, যে ডেন্সার মিডিয়ামের কথা বলতেছি এই ক্ষেত্রে কি ওয়াটার। ওকে, আচ্ছা, সো এভাবে দেখে রেখো তোমরা এই জিনিসটা। একটা 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 শর্ট একটা তোমাদের কুইজ, বলতে কুইজ না, একটা কোয়েশ্চেন, কুইজ তো আমি এখানে দিচ্ছি না। তো এখানে বলতেছে কি রিফ্র্যাক্টিভ ইন্ডেক্স অফ দ্য গ্লাস ফাইবার ইন আ ফাইবার অপটিক কেবল কত, 1.5। ফাইবার অপটিক কেবল হচ্ছে রিফ্র্যাকশনের সবচেয়ে বড় একটা উদাহরণ, যেটা আমরা ভবিষ্যতে দেখব, হুইচ উইল বি সিং অন দ্য কেস অন দ্য ফিউচার অফ দিস লাইট, নট অন দ্য নেক্সট পার্ট, অন দিস পার্ট। ওকে, so will be this is the original expression, the same as that of this. Instead of that, what the writer has done, he has shifted this v to here and n to here. So what should be the equation? If I shift this, v will be c divided by n or eta. Okay, so this is the mainly the equation. Okay, this is v equals to c by eta or n, where eta is the refractive index and c is the velocity of light in vacuum. Okay, velocity of light in vacuum, not on any medium, on any other medium. So with this formula they have got the answer 2 into 10 to the power 8 meter per second, which is the velocity of light through fiber of the glass fiber used in the fiber optic cable. Okay, so this is a general table which is not necessary to memorize, but if you look if you go through this table, I think inshallah you will understand what the refractive index, or that not understand this the refractive index, but you will understand that how many times is the velocity of light in that medium is less than the velocity of the vacuum, মানে কত টাইমস যে মিডিয়ামটা এখানে স্পেসিফাই করা আছে যত টাইমস লেসার, দ্যাট মিন্স ভ্যাকিউমের যে ভ্যালোসিটি কত টাইমস গ্রেটার এই মিডিয়ামগুলোর ভ্যালোসিটির চেয়ে, দ্যাট মিন্স ভ্যাকিউমের জন্য তো 1, যেহেতু ভ্যাকিউম তো এখানে সেম হয়ে যাচ্ছে, কেটে যাচ্ছে 1, এয়ারের জন্য কত 1.0029 টাইমস বেশি, ওয়াটারের জন্য 1.33, নর্মাল গ্লাস 1.52, then diamond 2.42, and it will go like this. But it is not necessary to memorize this table, to the informations given in this table. Okay, so a short quiz for you. Calculate the velocity of light in the mediums shown in 9.01. I think this is not that type of এটা আসলে এত কঠিন না, this problem is not that much hard. If you practice, I think if you understand the previous topics, then I think you can answer this one. So as the time is very limited, I will go to the answer of this question. Okay. Okay, so from that we have already discussed that V is equals to V is equals to C by N, that means velocity of light divided by refractive index of that medium, and accordingly as velocity of light in vacuum for each and every case is same, that is 3 into 10 to the power 8. We have only differed here, the only difference is that there has been replaced the refractive index with the mediums refractive index. It is for air, it is for glass, it is for I think water, no, this is for water, this is for glass, and this is I don't remember what okay, so from this equation, like the previous ones, you can easily find the velocity of light on that particular medium with respect to the velocity of light in vacuum medium. Okay, so loss of refraction of light, this is also an important topic for you. So loss of refraction of light is this part has been taken from the previous syllabus of your book. So what is happening here usually, the loss of reflection are mainly the fundamental loss which needs to be understood by each and every one of you, because if you don't understand or if you don't realize this loss of refraction of light, you will not understand the basic principle of refraction. That means you will not understand what refraction is happening and why do we need refraction and how light refracts from one medium to another medium. It either may be from denser to rarer or rarer to denser. It may be from any medium to another medium. So okay, we will not be discussing these parts, because this part has been discussed already on the first slide that I have discussed before. So we will be going from this time from this ratio that you are saying. I will be going through this. Okay, here it is saying that if the angle of incidence is increased, the angle of refraction will also increase, but the angle of refraction will not be proportional to the angle of refraction. That means what is happening here, that sorry, here it is saying that will also, but the angle of refraction will not be proportional to the angle of incidence. Okay, it can be said as vice versa. Okay, what is happening here, that the increment of the angle on increasing the incident angle. Suppose I have increased the incident angle to this. Let's say it is I1, then it is I2, and then I have further increased my incident angle. Let me call this as I3. Okay, so for these particular 3 incident angles, we will get naturally 3 refracted angles, and it will be increased gradually like the like as before the incident angle. Okay, then what will happen for I1, we will get R1. Then what will happen for I2, we will get an increased refracted angle R2, and for R3 we will get a further increased refracted angle R3. But here it is saying that angle of refraction should not be proportional, will not be proportional to the angle of incidence. That means the rate of increment of the incident angle, that means যে হারে ইনসিডেন্ট অ্যাঙ্গেলটা বাড়বে, ইনসিডেন্ট অ্যাঙ্গেলের যে মানটা বা ম্যাগনিটিউডটা বাড়তে থাকবে, সেই হারে রিফ্র্যাক্টেড অ্যাঙ্গেলের ম্যাগনিটিউডটা বাড়তে থাকবে না। দ্যাট মিন্স আই যদি 2 টাইমস বাড়ে রিফ্র্যাক্টেড অ্যাঙ্গেল 4 টাইমস বাড়তে পারে, অথবা 1 টাইমস বাড়তে পারে, 3 টাইমস বাড়তে পারে, বাট নট যে 2 টাইমসই বাড়বে, এই কেস হবে না। ওকে, এই কেস হবে না। দ্যাট মিন্স আই যতটুক বাড়বে আর ততটুকুই বাড়বে না। এবং এই যে বাড়তেছে না, এই বাড়াটা যে না বাড়তেছে, এই জন্য কি তাদের যে ভ্যালু তাদের কি সেম থাকতেছে না। দ্যাট মিন্স তাদের রেশিও দিলে একটা কনস্ট্যান্ট রেশিও পাওয়া যাবে। দ্যাট মিন্স এখানে আমরা যদি ইয়ে বলি, যেটাকে আমরা স্নেলস ল নিয়ে আমরা বলতে পারি, যেটা আমরা বলতে পারি স্নেলস লতে, অ্যাকর্ডিং টু দ্য figure it is quite difficult to understand the Snell's law, but if we go to the Snell's law on the original statement on the Snell's law, that is the second law of refraction, we will be easily understanding the thing. Okay, so at first let me let me at first discuss the first law of refraction. That means, what is the first law? The first law is that the incident ray normal drawn at the point of incidence and on the surface of separation, and the refracted ray lie on the same plane. That means the incident ray, what is the incident ray here? Let me erase this all these things. Okay, let me erase this figure because as it will be clear if we erase all the things in this figure. Okay, let us again go to the pen. Okay, you can see here that this is the incident ray. Okay, this is the incident ray. Then they have said that the normal, what is the normal here? The normal is the, this is the normal. Okay, this is the normal, I have said before on the previous slide, I think on the first slide, after the video has been played. Okay, this is the normal, and what is has been saying that the refracted ray. Okay, let us go. Okay, the normal drawn at the point of incidence on the surface of separation. Okay, we have to know also the surface of separation. What surface of separation usually mean? Surface of separation usually means that this is the surface of separation. Why this is called the surface of separation? Because it has separated 2 media. This surface of separation has separated 2 media. One is the rarer media, that is air, and another is the denser media, that is denser medium, that is glass. It has separated 2 media. So as a result of that, we are calling this line, that is PQ, as the surface of separation, SOS, or surface of separation. And this is called the normal, this is called the normal, this is called the incident ray, and this is called the refracted ray. Okay, and so on. So all will lie on the, what the first law says, that it will all lie on the same plane. On same plane means this is the plane that the first law is saying, that it is the two-dimensional plane which has both coordinates x and y. It will be called 2D coordinates. So for 2D coordinates we will be having a plane that is called this plane. This is the 2D plane, and this plane mainly defines this plane that we are saying, that on the same plane the thing is that is discussed here, or that is stated here. Okay, so this is the mainly the thing, that all the incident ray, refracted ray, surface of separation, and the normal drawn on the from the that will go through the point of incidence and point of separation, it will all lie on the same plane. Okay, and second law, that is the main important law for you to be known, because with this law you will be doing in the future, inshallah, various types of mathematical problems regarding refraction of light. Okay, so you have to know this. So this is the important formula. Please note down if you have a note in front of you, and if you have also a pen in front of you, please note down these things. So what it says that for the second law, when light enters obliquely means perpendicularly. Obliquely, it is a synonym of perpendicular. যখন মানে বাংলা we are saying it, and again as বাংলা for better understanding, যখন লাইট কি লম্বভাবে বা অবলিকলি ভাবে বা পারপেন্ডিকুলার ভাবে যখন ইনসিডেন্ট করবে বা পড়বে to a transparent medium, that means to a transparent medium means that it is visible. The light, if we see from outside, we will see that an object is here. That means light can go through this medium, and we all know that the medium through which light can't go is called opaque medium, and one of the most common opaque medium in this universe is the black hole. The black hole is a complete opaque medium from which light will not pass through it, and if it passes, it will absorb energy of the light, and if an observer wants to look from outside, he will see no light, or he will see simply a black thing. That means light has not passed through it, or we are not light is that means that the medium is not visible from that area. So that will be called an opaque medium. There are also other opaque mediums, but this is the ideal opaque medium, which is the black hole. Okay, so if light enters obliquely to a transparent medium from another transparent medium, so for this এই কারণে আসলে আমরা এখানে ট্রান্সপারেন্ট মিডিয়াম কথাটা আমরা বলছি। এখানে আমরা স্বচ্ছ, যেটাকে বাংলায় বলা হয় স্বচ্ছ মাধ্যম থেকে আমরা এই কাজটা করতেছি। দ্যাট মিনস স্বচ্ছ মাধ্যম এখানে আমরা নিছি, যেহেতু লাইটের এখানে আদান প্রদান হইতেছে, লাইট যাচ্ছে একদিকে গিয়ে বেন্ট হয়ে যাচ্ছে, তাই না? আচ্ছা, অ্যানাদার ট্রান্সপারেন্ট মিডিয়াম, অ্যান্ড দেন ফর আ ফিক্সড পেয়ার অফ মিডিয়া, ওই মিডিয়ার পেয়ারের জন্য, দ্যাট মিনস দ্যাট ফর দ্যাট পার্টিকুলার ফিক্সড পেয়ার অফ মিডিয়া and for a fixed color of light, that means the color of light also varies here, also matters here, because for different color of light we will see different types of refraction. That means we will see different types of refraction angle. Instead of যদিও এটা যদি ইনসিডেন্ট অ্যাঙ্গেলটাও হয়, if it is the case that the incident angle in both the cases are seeing the same, we can say that the refracting angle or refraction angle will be the same because of this color of light, fixed color of light, for which it has been also included in this second law. For fixed color wave, the ratio of the sign of the angle of incidence. What is the angle of incidence? I. Sign of angle of incidence is what? Sin I. Okay, sin I. Ratio of the angle of incidence, sine of the angle of refraction. What is the sine of the angle of refraction? Sin r. That means this is the ratio. Okay, this is mainly the ratio which has been stated in this second law. The ratio of the sine of angle of incidence and the angle of reflection will be a constant, and this constant will be what we will be calling also this constant as eta. That means eta or n. That is, what is eta or n? Eta or n, which has been discussed already. The eta or n generally defines the refractive index of that medium. Okay, the diffractive index of that particular medium is mainly denoted by eta or n. Okay, this is n and this is eta. Okay, so this the mathematical expression which we are calling this, that sin I by sin r equals to eta, this mathematical expression mainly means the mathematical form of Snell's law, or if we express it in as theory, will be if we express this form, mathematical form, as theory, we will need to give the definition like this, that when light enters obliquely from a transparent medium to another transparent medium, then for a fixed pair of media and for a fixed color of light, the ratio of the sine of the angle of incidence and the angle of refraction will be a constant, and that constant will be eta or n, which is called also known as refractive index. And this is mainly in theoretical concept, it will be called Snell's law or theoretical form of Snell's law, but I have expressed here mathematically, this will be called mathematical form of Snell's law. Okay, okay. Second law of refraction, I have also included this because on the new syllabus it has been provided like this. The second law of refraction can be also stated mathematically like this, that is eta 1 or n1. N1 is the refractive index of first medium, that means the incident medium. Okay, the incident medium, যে ইনসিডেন্ট মিডিয়াম যেখানে লাইটটা ইনসিডেন্ট করবে সেটাকে আমরা বলছি কি ইনসিডেন্ট মিডিয়াম, সেটা রিফ্রেক্টিভ ইন্ডেক্স কি n1 অথবা eta 1, আর যেটাতে লাইট রিফ্র্যাক্ট করবে, দ্য মিডিয়াম অন হুইচ লাইট উইল বি রিফ্র্যাক্টেড উইল বি কল্ড n2. The refractive index of that medium will be n2. Okay, n2, then that means it is the second medium or the refracted medium. Sorry for my writing, as I am writing to a capacitive stylus, my writing is not that good, for that reason. Okay, the second medium will be called the refracted medium. Okay, so when we will be expressing the refractive index of two mediums as the separate refractive index, we will be using this formula, that means n1 sin theta 1, where theta 1 is the angle of incidence, it is the angle of incidence. Okay, I, and theta 2 which is the angle of refraction, or simply we can say small r. Then we will be using this formula, that is n1 sin theta 1 equals to sin n2 sin theta 2, and we will be if one of the term is not known, that means let's say that you have been asked to find out the refracted angle after incidenting on the first medium, then what you will do, that you will simply use this formula where you know n1 n2, that means refractive index of the incident medium and refractive index of the refracted medium, and you know the incident angle as well, that is sin theta 1, then you will be easily obtaining the theta 2 angle. Okay, from the inverse formula or inverse relation, which some of you might know or some of you don't know this. Okay, so okay, that is the main thing. And when n1 is 1, that means when the incident medium is vacuum, and on the vacuum or air, because air on the refractive index of air is almost 1, if we say from this perspective, from this table, you can see that the refractive index of vacuum air are more or less the same, that means 1, though we can see some after decimal some digits, but that's not our main point. We can say that the refractive index of vacuum and air are same, and that is 1, but it is only ideally, not physically, the refractive indices of both the medium are same. Okay, you have to also understand that, or you have to also note down that. Okay, it is for ideal case for which refractive index of air and vacuum are seen the same, that means 1. Okay, on only 1. Okay, so then the formula will be like this, because n1, okay, let me derive it, n1 sine theta 1, the formula, the previous formula, previous slides formula, sine theta 2, if n1 is 1, then it will be 1. Okay, then what will be seeing, the remaining thing, sine theta 1 equals to n2 sine theta 2. Then if you divide both the sides of the equation with sine theta 2, or if you take the sine theta 2 part to here, it will be divided. Okay, then sine theta 1 sine theta 2 will be your required answer, and where it will give you the output or the ratio, that is n2. That means this is mainly the another form of Snell's law, where if you place the value of n1 or the incident medium as 1 and the refracted medium is as n2, not 1, then you will get again this type of formula, which is also an alternative form of Snell's law. Okay, this is also an alternative form of Snell's law. These are the general things. This will be understood by you easily if you go through all of this, as these all things will be given to you, slide, as well as the this part has been taken from your present syllabus books of syllabus book of physics. Okay, so this is mainly the previous things what I have discussed, that from rarer to denser the angle of refraction will decrease, and from denser to rarer, if that light incidence from denser to rarer, the angle of refraction will increase. Okay, that is the main thing. Okay, okay, and now I have written here that alternatively from the book of the previous syllabus we can also define the Snell's law as that this form, that this is the main form, a eta b. What does it mean, a eta b? A eta b generally means the refractive index of B medium with respect to A medium. That means we are calculating the refractive index of medium B with respect to which medium? The A medium. If this is the A medium and this is the B medium, then we are calculating refractive index of B, but with respect to another medium, which is the incident medium, that is A. We have to write it as this type. Okay, the same thing I am writing in the board or the white part of the slide, you can say. So what I am writing here is that A eta B, that means refractive index of B medium with respect to which medium? A medium. Okay, this will be called as this type. Okay, this is the mainly the form. Okay, not this the one that the writer has given. This is not the correct way of representation. If you write in your with your hand, or if you write with the pen or paper, okay, this is not the representation. The correct representation is where this denotes the subscript and this denotes the superscript. On the superscript position you have to write A, and on the subscript position of eta you have to write B. Okay, then it will be called that refractive index of medium B with respect to medium A. Okay, okay, so that will be also the ratio between sine of angle of incidence and the key sine of angle of refraction. Okay, this is also another alternate form of Snell's law as given by the previous syllabus book. Okay. Okay, this is also another a basic what I can say, that basic types of mathematical derivations which has been derived from the based on the perspective of your refractive index law or refractive index principle. What it has been stated here is that you can say, if you say that light incidence from medium A to B, let me draw the figure as a sketch here. Okay, let's say it is medium A and this is medium B. Okay, if light incidence from medium A to B and it will let us say A is the rarer medium and B is the denser medium, then it will obviously R will be okay, with the normal I will be I will be greater than R, okay, it in this case, okay, as this is the, we have considered it as the denser medium and this as the rarer medium. So if light incidents from denser medium to rarer medium, যদি লাইট ইনসিডেন্ট করে বা টাচ করে ডেন্সার থেকে অথবা কম ঘনত্বর বস্তু বা অবজেক্ট থেকে বেশি ঘনত্ব অথবা কি ডেন্সার মিডিয়ামে, then it will be seen. And if we express refractive index of A with respect to B, what we will be doing here? We will be doing simply, we will be doing what is that? We will change the ratio. That means in this case it will be sin R by sin I, as the light is incidenting from A to B. So if we want to get the refractive index of medium A with respect to B, I am saying again, we are not finding out refractive index of medium B with respect to A, we are finding out refractive index of medium A with respect to B in this case. So the ratio will be reversed. You can see here from there sin R divided by sin I, okay, which is again equals to 1 divided by sin I by sin R, which is again can we say 1 divided by refractive index of B with respect to A, okay. This is the main expression, because you know that sin I by sin R from your previous slide, you can see that sin I by sin R is called A eta B or A and B, by which you can it is your wish by which symbol you want to express refractive index, both is correct, okay. So A eta 1 by A eta B will be B eta A, okay. This is a fundamental formula. You don't need to memorize these parts, okay, the parts that are discussed or written here, because it is basically a mathematical derivation that has been stated here, okay. So you have only what you have to do, you have to memorize, I am saying again, you have to memorize this part, okay. Without memorize you will not be able to answer the questions, okay, in the exam mathematical questions, okay. So what is happening, that B eta A will be equal to simply 1 by A eta B, that mainly is the formula that is first derived, and you have to memorize this, okay. This is the first formula. Okay, then with this formula there has been another okay, no, not that, let us come to this, okay. We can write again A eta B, okay, this is the equal sign, this is not the minus sign, this is not the minus sign. A eta B can be again said as velocity of light in medium A divided by velocity of light in medium B. That means you can say that refractive index of the refracted medium with respect to the incident medium will be equal to ratio of the velocity of light of the incident medium, that means medium A in this case, divided by ratio of the ratio of the velocity of light in incident medium and the ratio of the velocity of light in refracted medium, that is here in this case medium B, okay. You can say like this, okay. This is the basic another formula. If and why are we using this or why are we stating this formula? We are stating this formula that's because we want to, if it is said in your question, we'll be going through these questions on our future slides. You will face that types of questions. That is, suppose you have been stated velocity of light in medium A, suppose of the incident medium, suppose in this case, and you have been given velocity refractive index of medium B with respect to A, you have been also been given this, okay. Then it has be it will suppose it will the question wants that find the velocity of light in medium B. you have velocity of light in medium A known to you. You have refractive index of medium B with respect to a medium known to you. You have to find out the velocity of light in medium B. What you will do? You will just simply interchange the position. Okay, interchange the position. That what will happen here? Velocity of light, let us say CB in medium B. Let us say suppose what it will be, velocity of light in medium A divided by refractive index of medium B with respect to what, medium A. That will be your general expression then. Okay, that will be your general expression. This is CA. Okay, this is CA. The one those students who are not able to see this, this is called CA. Okay, or velocity of light in medium A. That means velocity of light in medium A divided by A eta B will be your required CB. That means velocity of light in medium B, which will be easily solvable to you. Then after that, if you know this equation, then it will be only solvable to you. Otherwise it will not be solvable. Okay, that's why they have stated this formula in your book on based on the previous syllabus, not the okay. This is another quiz mathematical example type. Okay, this is another mathematical example which you might face again on your exams as well. Okay, when light refracts from air to water, the angle of incidence is 30 degree. Okay, the angle of incidence is 30 degree and angle of refraction is 19 degree. It is stated on the question যে তোমাকে কি বলা হয়েছে, I am saying it Bengali and I am repeating it in Bengali. তোমাকে বলা হয়েছে কি, লাইট রিফ্রেক্ট যখন করবে এয়ার থেকে ওয়াটারে, তাহলে এয়ারটা কি, এখানে এয়ারটা হচ্ছে রেয়ার আর মিডিয়াম, তাই তো, রেয়ার আর মিডিয়াম। আচ্ছা, আর ওয়াটারটা কি এখানে denser medium. কেন denser medium? কেন? Why they are being called so? Because as rho W is greater than rho A, that means density of density of light in water is greater than density of light in air, and that's why we are saying that air is the rarer medium and water is the denser medium in this case. Okay. Okay, so in this case we are saying that the angle of incidence is found 30. That means I equals to 30. Okay, I equals to 30 degree. Okay, 30 degree, and angle of refraction is 19. That means এখানে কি angle of refraction তাহলে হচ্ছে কি 19 degree. Okay, 19 degree. Okay, তাহলে বলছে কি refractive index, find the refractive index of water with respect to air. What you have to find here is that find the refractive index of water with respect to air. That means if you express it in mathematically, it can be said that refractive index of on the subscript position you have to write W, and here you have to write A. That means refractive index of water with respect to which medium? Air medium. So this is a simple math, because from this formula you can derive it easily. Okay, from sin I by sin R. Okay, A and W equals to ki sin I by sin R. You can easily get this, then you will easily get this value A eta W, or refractive index of water with respect to air. And this mainly has been done on your book as well. Just they placed the angle of incidence and angle of refraction value, and they got, after some mathematical operations, algebraic operations, simple algebraic operations, or through your calculator, you will obviously get the value of sin 19, and you know sin 30 degrees half, as it has been stated, 0.5. So it will be equal to 1.538. Okay, something. So this is the required refractive index of water with respect to air. Okay, now on the second example, based on the previous example, I think it is a new okay, the numerical value is new here. Okay, suppose you in this case you have been told that the refractive index of water with respect to air is 1.33 on the next example, and you have to now what you have to find is that you have to find the refractive index of air with respect to water. That means there has been given refractive index of water, that means A eta W as 1.33. What you have to find? A eta W eta A, that what you have to find. So how you can find this expression? That means W eta A or WNA, simply WNA, from this relation that also was discussed a bit ago. Okay, a while ago it has been discussed on your previous slides. By using this formula you can certainly get this, and it will be 1.75. okay, and there must arise a question in this case. The question is that why the reverse one, that means the refractive index of air with respect to water is seen the less, why, while the refractive index of water with respect to air is seen the most or more, seen more, but for the inverse one, that means refractive index of air with respect to water is seen the least or less than the previous one. This is happening that because we are what we are mainly want to know, we want to know the refractive index of air, okay, but with respect to another medium. So you know basically that the refractive index of any medium which has lesser density has lesser refractive index, and the refractive index of any medium which has higher density has higher refractive index. So as a result of that you are getting here 0.75, but in case of water with respect to air you are getting it 1.33, and you can also validate this statement using this table. Okay, let me go to through this table. This table will give you the better understanding of this statement that I have said previously. Okay, that means what I have said, that as air is denser than vacuum, it has greater refractive index than vacuum. As water is much denser than air, water has much refractive index than air, and it will go so on. So that's why I have previously attached the table from your book of this refractive index. Okay, from that's why I have included this table for a better understanding of all the mathematical problems which I have discussed a while ago. Okay, until now. Okay. Okay, let me go to the another example, another thing, that is the critical angle. Sometimes it is seen that instead of refraction, okay, instead of refraction angle being okay, from one, let us start from the beginning. When light incidents from denser to rarer medium, in some cases it is seen that for a particular incident angle the refracted angle becomes 90 degree instead of being not like this. You can see from here what it should look like usually, as because the medium is going from denser to rarer medium. Okay, that means the medium is the light is incidenting at the denser medium and refracting at the rarer medium. So in this case the refracted angle should be greater than the incident angle. That means I is less than R. It should be here. Okay, so there we can practically say that. Okay, so okay, but for a particular angle it is seen that incident angle, it is seen that instead of refracting at an angle like this, which is less than 90 degree, of course, it will refract through an angle 90 degree. Okay, through an angle 90 degree, and the angle, that specific angle for which we are getting the refracted angle as 90 degree, mainly is called the critical angle. Okay, this is as simple as that. It the all the elaboration we are seeing here is only the discussion or the geometrical elaboration of all the things, the phenomenon that is happening here. So what is happening here, that the incident angle, instead of for a particular incident angle, we are getting the refracted angle as 90 degree instead of like this angle, which is less than 90 degree. Okay, so and on the on the contrary, we can also say that the refracted angle, refracted ray goes through the separation of medium, which we have also discussed before. What is this? What is separation of medium? It will go through the separation of medium, through the line or through the path of the separation of medium, and this is mainly called what we call the incident angle, for which we are getting refracted ray as 90 degree, is called critical angle. Okay, this is mainly what we are calling critical angle. Okay, and now total internal refraction. Okay, total internal refraction, what it mainly is, that from here you can see the figure is given here, but the discussion is given on the next slide, but I will not be going through this. I will be going through this because here, as the figure is stated here, and we have a limited amount of time, we have a short period of time, that's why will not be going through the discussions. So when if the angle of incidence on the previous example or the previous discussion, we have said that we are getting a type of incident angle which is critical angle, for which the refracted angle becomes 90 degree. Okay, now instead of this, if we do such a thing that we are again increasing the angle from the critical angle to another type of angles, let's say the critical angle is 45 degree. Okay, let's say that the critical angle is 45 degree, we are increasing this value to greater than this. Suppose let us think 45 degree, then 60 degree. Let us say for rarer denser medium, let us say the incident angle is be 60 degree. So in this case, what will happen, instead of refraction, what it will do, it will follow the principle of reflection. Okay, yes, you heard it right. That means what the principle of refraction does, that through a medium, through a mirror or a reflective medium, when light incidents on the normal or separation of normal and the plane of the refracted plane, then it will go back to the same medium. Okay, it will reflect back to the same medium, what we usually call the phenomenon what we usually call the phenomenon as reflection of light. Okay, so in this case, what is happening here, that when the incident angle is further increased from critical angle to a definite value of angle, let's we have said that let it be 60 degree, what it will do, it will follow the reflection phenomenon. That means it will reflect back to the medium on which the incident of light has taken place. That means it will not go to the air medium, that means it will not traverse a distance on the air medium, and that's why this is called, what the phenomenon is called here, total internal reflection. The light is totally reflected internally. Why it is called total internal, that the main reason of saying it as internal reflection, that is because it is happening within the same medium on which the light is incident. Okay, so we are saying that as total internal reflection. Okay, total internal reflection conditions, it should be, at the first we have said, it will be light will incident from denser medium to rarer medium. Okay, and it will also be applicable for, let me say for, okay, sorry, for critical angle as well. Okay, for critical angle to be created, this is also the same this is also the same what you can say, the same reason or same conditions. Okay, তার মানে এখানে আসলে কন্ডিশনটা কি হচ্ছে যে ক্রিটিক্যাল অ্যাঙ্গেলের ডেন্সার থেকে রেয়ার আর মিডিয়ামে যেতে হবে লাইটটাকে, এবং কি লাইট ইনসিডেন্ট করতে হবে অন দ্য সারফেস অফ সেপারেশন অফ ডেন্সার অ্যান্ড রেয়ার আর মিডিয়াম, দ্যাট উইচ হ্যাজ বিন সেট clearly in this case also. Okay, এবং at the same time we have to also consider the angle of incidence in denser medium must be greater than critical angle in case of total internal reflection. Okay, it is only applicable for total internal reflection. Angle of incidence in the denser medium must be greater than what? The critical angle, that particular type of value, that is theta c, that you have read. Yeah, this is the critical angle that you have that was discussed on the book in a clear manner. Okay, on the it was on based on the previous syllabus. Okay, okay, so this one is the thing. And you can also generate you can also get your critical angle using the Snell's alternative form that already has been discussed on the new syllabus of the book that I also have discussed with you before on the previous slides. Okay, what is happening here? The theta 1 there has been considered 90 degree. That means here theta 1 represents the rarer medium. Okay, that means theta 1 means the reflected angle in this case. Okay, then eta 1 is that the refractive index of the first medium. Okay, sorry, on the refracted medium, that is here in this case air, and theta c is the incident angle, as because we are getting 90 degree as refracted angle in this case. So theta c is incident angle is theta c and refracted angle is 90 degree. So if we do basic types of interchange and these types of things, then we will get this expression, that is sin theta c will be equal to eta 1 divided by eta 2. That means sin theta c will be equal to n1 or n2. That means the ratio, what eta 2 is here, it is not the for the this is not the incident medium refractive index for according to the discussion of their book, but you can also derive it as by considering it as eta 1. Okay, according to your wish, and considering eta 1 as eta 2, it will be, then I think it will be understandable, clearly understandable to you. Then what will happen here? Sin theta c will be eta eta 2 divided by eta 1. Okay, eta 1 or n, what by which expression you denote. Sin theta c will be what? Eta 2 divided by eta 1. Okay, eta 2 divided by eta 1, where eta 2 represents the refractive index of the refracted medium, and eta 1 will be denoted as the refractive index of the incident medium. Here in this case is air, the incident medium, and the refracted medium here in this case the incident medium here in this case is in this case is air, water, and eta 1 is in this case is air. Okay, this that's only the eta 2 is the refractive index of the water, and eta 1 is the refractive index of air. Okay, eta 1 is the refractive index of air and eta 2 is the refractive index of water, and so like that. And if we do the inverse operation, we will get like this. Okay, that means we will take simply the sine inverse operation on here. That means the sine inverse operation is like that: sine inverse x, sine inverse y, sine inverse z. It is to be mentioned to you that these inverse operations are not discussed in your this syllabus. That means on the class 9-10 and SSC level syllabus, as well as I think on the O level syllabus as well, it has not been discussed. এখানে তোমাদের ডিসকাস করা হয়নি এই জিনিসটা, বাট মনে রাখবা যখন তুমি এইরকম কোনো রেশিও পাবা যেখানে একটা সাইন দেওয়া আছে আর রেশিও দেওয়া আছে, what you will do that you will simply take the sine inverse if you want to find the theta c, or here in this case critical angle. Okay, you will take the sine inverse. If we, that means what will happening, you will consider that we are dividing sine here, like, not, it usually means that, it doesn't usually mean that, but you will think that here we are dividing eta 1 by eta 2 with sine. So as we are dividing eta 1 by eta 2 with sine, from any exponential case, as you have studied on your higher math portion, I think that if we want to express 1 by 1 divided by x, that means any denominator with respect to numerator, we can express algebraic form as x inverse 1. We can easily understand that, we can easily express that, and we are also expressing here like that we are dividing sine, so we are taking here sine inverse here. Okay, we are taking here sine inverse instead of dividing sine with it, as it doesn't necessarily mean that we are dividing here the expression of ratio eta 1 by eta 2 with sine. We are taking here the sine inverse ratio. Okay, this is the only thing that you have to understand well, why here we are giving theta c equals to sine inverse n1 by n2 or eta 1 by eta 2. Okay, this is another simple question by which we can denote the critical angle. There has been given incident the okay. This had been a tricky question, but this can be solvable, because the incident, when light incidents at an angle of 75 degree from a medium of refractive index 1.5, with what angle will the ray of light emerge if there is air on the other side? বলতেছে যে মানে there it is saying that let us suppose on the other side there is air. Okay, that is here in this case we are telling that the denser medium অথবা এখানে বেশি ঘনত্বর বস্তু যা বা জায়গাটা হচ্ছে কি এখানে ওয়াটার, অথবা ধরলো এখানে ফ্রম আ মিডিয়াম, এটা একটা বেশি ঘনত্বযুক্ত বস্তু, এখানে বলে নাই ওয়াটার বা অন্য কোনো কিছু কিনা, বাট এখানে বলছে যে here it has been said that it is a much denser medium. Okay, so from denser medium to a rarer medium, that is the air, or emerge. If there is air on the other, will the ray of light emerge? Okay, emerge মানে কি বলতেছে আসলে এখানে? ইমার্জ বলতেছে যে ইমার্জ বলতে এখানে বাংলায় যেটা হোয়াট উই ইউজুয়ালি মিন ইন বাংলা, দ্যাট ইজ দ্য ইমার্জ ইজ সামথিং দ্যাট কামস আউট. ওকে, that is the mainly the thing. Okay, so we can do with this formula as well, using this formula eta 1 sin theta 1 or sin theta 2 or eta 2 sin theta 2 by representing eta 2 as 1 and eta 1 as 1.45, and sin theta 1 is known, that is 75 degree. Then we will usually find this expression, and with the help of inverse operation, that means theta 2 will be sine inverse 1.4. As we have said that we are assuming that we have divided sine on the right hand side, so we will get something value, and that value will be equal to 43.6, and we can also denote it as critical angle by considering the refracted angle as 90 degree. But this is not the basic thing, this is not the effective way of performing such types of mathematical problems, because it is not said that it is the critical angle in this case. Okay, acha. Okay, the practical of application, this is mainly what we call the formation of rainbow, which will be dealing from the practical applications. So let us see. So this is the practical demonstration of how a rainbow formed.
A ray of light is made up of the same 7 colors seen in a rainbow. This is seen when a ray of light is shone at an
Let
angle
us see
to
the
a prism.
demonstration video. I think it
triangular
will be
shape
clear
of glass.
a bit.
Light slows down as it goes from air to glass and causes the ray of light to bend. This is called refraction. Each color in a ray is bent at a different angle, allowing 7 colors to be seen. The red light gets bent the least, while the violet light bends the most.
This is called a
Sunlight,
prism.
therefore, is
What
key to the science of rainbows.
the figure
Light travels
on the
more
previous
slowly through water than
one
air,
usually mean.
so that raindrops act as prisms, bending, separating, and
Okay,
reflecting the
and
light that
here
comes through
we
them.
can see that raindrops
see a rainbow
is
because the
is made
separated
similar
light
to
is
the
reflected
prism
to
that
our
was
eyes.
discussed before, and like that it does many types of refraction, various types of refractions, and like that, suppose this is a prism or raindrop. In this case you can say this is a raindrop or prism, and here after incidenting of the white light, that is a mixture of 7 colors, you will see that after refraction, after several refraction, why we are saying it several refraction, that is because after incidenting it refracts here, and after again and going through this medium it again refracts, and like this it produces 7 colors of a rainbow. Okay, this is mainly the principle of the operation of forming light 7 colors of a rainbow, which is similar to the prism principle, because we are considering the prism here as an example. Okay, but in this case the it is not the prism, it is the raindrops which are causing the repetitive refraction. Okay, the repetitive refraction which is causing to produce 7 colors, and then it is mirage. Mirage, or in Bangla we can say মরিচিকা, that is said in বাংলা মরিচিকা, অথবা যেটা বাংলা আমরা ইংরেজিতে বলছি মিরেজ। ওকে, তো মিরেজ এটা হচ্ছে আর একটা প্র্যাকটিক্যাল অ্যাপ্লিকেশন, সেটা কিভাবে তৈরি হয় সেটাও আমরা একটু দেখে নিই।
What is a mirage?
An invisible cloak.
No. Mirage is an illusion in which it appears as if there is water present on the ground. On a hot
একটা
day,
illusion
the land
বোঝাচ্ছে,
heats the
যেহেতু
layers
তোমরা
of
audio
air
শুনতে
closer
পারছো না,
to
as you are
it.
not
However,
hearing
as
the
we move
video,
higher,
audio.
the layers of air get relatively cooler.
একটা
Thus,
দুইটা
the
লেয়ারের
hot
একটা
lower layers of
বলছে
air near the
যে
ground form
relatively
rarer
cool হচ্ছে,
media,
one
and
type
cold
of
upper
rarer
layers
মিডিয়াটা
form
হচ্ছে
denser
যেটা
media.
কুল মিডিয়া, সরি
Now, when light
rarer
coming
মিডিয়া হচ্ছে
from
কুল
sky
লেয়ার, আর
travels from
ডেন্সারটা হচ্ছে
denser
হট
to
এয়ার,
rarer media,
বুঝাচ্ছে
it bends more and more until it exceeds the critical angle,
এখানে
that
critical
is,
angle
the
exceed
angle
করতেছে
beyond which
বলতেছে।
light gets reflected. This phenomenon is
তারপরে
called
হচ্ছে কি
total internal
রিফ্লেক্টেড হচ্ছে,
reflection.
যেটাকে বলছি
When
আমরা
this
টোটাল
reflected
ইন্টারনাল
light reaches
রিফ্লেকশন,
our
যেটা আমরা
eyes,
একটু আগে
our eyes
পড়ছি।
trace it
ক্রিটিক্যাল
backward as a
অ্যাঙ্গেলের
straight
এক্সিড
line.
করতেছে ইনসিডেন্ট
Hence,
অ্যাঙ্গেলটা।
the reflection
in
of
this
blue
case.
sky appears on the ground, and our brain
সো
thinks that there
এমন
is
একটা মনে হয়
water,
লাইটের
thus
রিফ্লেকশন,
causing a
স্কাইয়ের
mirage.
রিফ্লেকশনটা এমন ভাবে মনে হয় যাতে মনে হবে কি সেখানে পানি আছে, মরুভূমিতে এটা ইউজুয়ালি হয়। ওকে, যে উপরের লেয়ারটা কি থাকতেছে, কোল্ড থাকতেছে, যেটা অ্যাজ ইউ ক্যান সি ফ্রম হেয়ার। ওকে, কোল্ড থাকতেছে, আর নিচের এয়ারটা ইউজুয়ালি কি হট থাকতেছে। তাইলে এখানে হচ্ছে কি ডেন্সার মিডিয়ামটা হট এয়ার, আর রেয়ারার মিডিয়ামটা কি কোল্ড এয়ার। তো লাইট কি করবে ইনসিডেন্ট ডেন্সার থেকে রেয়ারে, ডেন্সার কি হট, তখন রেয়ারারটা কি এখানে কোল্ড, তো ডেন্সার থেকে রেয়ারার কি কোল্ড এয়ারে যখন রিফ্লেক্ট করতেছে তার ইনসিডেন্ট অ্যাঙ্গেল কি ক্রিটিক্যাল অ্যাঙ্গেলের চেয়ে এক্সিড করতেছে, ইট উইল এক্সিড more than the critical angle, and then what will happen is there that here we will see a total internal reflection, and the reflected ray will be visible as this, the total internal reflected ray, which mainly specify here is that it looks like that here is a water source, because if it is a water source it will be seen like a image will be created on the water. We have obviously possibly seen that. And this is another quiz for you, explain another physical phenomenon of mirage, which is also seen on the pitch vehicle. You will, if you read that, it will also be found. And this is another application of the total internal reflection, which we usually call optical fiber. And in this optical fiber, within this optical fiber, you can see that core, this is fiber core, these layers are the core. Within the core there happens several types of total internal reflections, and with the help of total internal reflections we can see light on the other side, that is here the optical part on the other side, and this is mainly the another operation of the total internal reflection of light. Okay, so this is another question, please solve it for yourself. And this is another other applications of the optical fiber in the field of health and telecommunication, which is also necessary to you, because especially on the case of MCQ, there may come from here this slide some topics. It has been taken all from the previous slides, sorry, from the previous syllabus. Okay, so thank you all. Hope I have taken a lot of time for your for discussing all of these things, but it is a topic which can't be completed within one class. It should take more than 3 or 4 classes, because there are also other more topics that are remaining. Some of them are lens, then optical lens, then how a spectacle works, and so on. So this is mainly was the first part of my video of